All right. Welcome back. We're going to jump right in, get our brains back into high gear. This is a review of past ideas that you were supposed to have mastered, and it is also a lead-in into today's lesson. So let's see how we did. I asked you to graph a situation, so calling on volunteers is not really going to benefit us in any way. So use your colored pen, mark your answer correct or incorrect, and then we'll talk about how. That is the graph you should have had. You might have had that there and that there. I was pretty impressed. I walked around and I saw a lot of people at those 2 points on their graph and then a line connecting them. So let's back up a second, because before you can graph, you need some sort of equation to graph with, or some points. So what equation did you write for the scenario? Start with Nathaniel, and then over here, and then over here.
Well, it started as a standard form equation, and I had to find the points.
Okay, so what you said a standard form equation?
Standard.
What was it?
It was 6x plus 8y equals 480.
Okay. 6x plus 8y equals 480. Okay? What'd you have, Caleb? You got the exact same thing? Same exact thing. Okay, and Nathaniel, I think you were about to say something else. What else did you do?
I would find the points of x and y intercepts. I would have to replace the y with the x with 0 and solve it.
Very good. That was a great explanation. So to find this point right here, this 80, we replace the y with 0, which makes this term disappear, and you end up with this equation. And as he said perfectly, you then solve. And that gets you x equals 80. To find the y-intercept, this point right here, you make the x into a 0, which that term will disappear, and you end up with 8y equals 480. Solve there, and you get 60. X and y intercepts, connect the points. Go ahead, Kayla, and then Dalton. Slope-intercept form. So when you did put it in slope-intercept form, what did it come out to? Outstanding job. That is slope-intercept form. And were you able to graph it successfully? Now, I personally found, I did it both ways myself. I found this way hard because of the grid that I was given. Since the grid went by 20s, I found it difficult to go down 3 over 4. Did you find like multiples of it? Is that how you did it, or you just estimated and kept on going? Good. I'm glad. That's excellent. Okay, Dalton? Slope-intercept form? Good. So both methods work beautifully. My personal opinion, which doesn't matter, you do whatever you want, my personal opinion is when an equation is in standard form, like Nathaniel said, using intercepts is usually the quickest. Not always, but usually. Okay? Outstanding job. Does anyone have any questions or comments? So, at this point, halfway through the curriculum, you should be able to look at a scenario like this, and maybe with 20 to 30 seconds of thought, the equation should just pop into your head. Because you've seen this type over and over again. Now, we're coming off of vacation, so it might not have popped in your head so quickly, but over the next few weeks, you should notice yourself easily being able to pick up what was supposed to be written. Okay? Any comments or questions? Now, this is also a lead-in to today. So today we start chapter 7. Today's lesson is 7.1. You do not have to copy. I would like you to write notes because we're going to be eventually copying some notes, but I want you to just read along with me. So you can put your pencils down on your desk after you write the word notes. Chapter 7. This is the quintessential example of us taking concepts that we learned already and applying them in new situations. Because now you're going to start learning what is called a system of equations. I'm going to explain what that means in a few minutes. But you're going to learn how to solve a system using 3 different methods. The first method is called graph and check, and that's what you're going to learn today. So you're going to be graphing. The second method is called substitution. You will learn that on Wednesday. And the third method is called elimination. You will learn that on Friday. 3 different ways of solving a system. Now you don't even know what a system is yet. You'll learn it in a couple of minutes. The second and more important goal is to learn how to take a system and apply it to a real-life scenario. Kind of like what you did during the warm-up, although that was just one situation, not a system. We're going to finish the chapter by studying systems of inequalities, which is definitely pretty darn challenging. The whole chapter is challenging, but you're used to that already. In fact, it's a new year, and you should feel pretty different than you did the first day you stepped into my classroom. In fact, if you didn't realize it, you've completed 1 full semester of Algebra 1 honors. You should feel different now. Your brain should not be functioning the same way it did when you first came into my room back in August. Okay? Does anyone have any questions or comments about these overall goals? Good, you shouldn't, because you don't even know what I'm talking about yet. So let's talk about systems. So now you are going to be doing some writing, but use lots of abbreviations, like the word variable can be abbreviated VAR. A system is 2 or more equations with the same variables together. That's called a system of linear equations or a linear system. I will probably just say linear system, or I might even just say system. When you hear the word system, you know I'm talking about 2 or more equations at the same time. Over the course of the first 6 chapters, you became a Jedi Master of working with 1 equation. So working with 2 is not actually that huge a leap. It's just learning how to do both of them at the same time. Now, we are going to be solving systems, so we need to understand what that means. So a solution of a system is an ordered pair. Now this might frustrate you for a minute, but I'm just going to hide this. And I want to refer back to my map in the back. When you first started with me, and we spent the first few weeks doing some basic skills, but then we got into chapter 3. And look at the top row. You learned how to solve, with the exception of the last poster. You learned how to solve all of those. When you solved them, for example, the second one, 8x minus 1 equals 81. When you solve that, what do you get? I don't want the answer, I want to know what does it look like. When you solve that, what do you get? Okay, but what does the solution look like? Does it look like a shape? Does it look like a letter? Does it look... Okay, it's just a number. Do you know what that one is specifically? Anyone know what the answer to that is? You should. Yeah, x equals 10. So you get a number. X is 10. Now, look at down, let's say over here. What does a solution to an equation like that look like? What's a solution to that? Because first it was a number, but Janae, now I want to know, what does the solution to that look like? Only one person may have an idea? Okay, now I'm going to turn your attention back up here. Let me go back to the warm-up for today. What does the solution to this look like? What is it? Nobody knows what a solution? That's a problem. Because you should instantly know what a solution to that looks like. Is it a letter? Is it a number? Is it a shape? What is it? John? It's a number, like 10. Unfortunately, that's not correct. I try not to say that my students are incorrect, but unfortunately that's not correct. And you should know at this point what a solution to this looks like. We've actually talked about this repeatedly over and over again, and we looked at it in different contexts. So you can't walk out of this room today without knowing what a solution to that looks like. What does it look like? Dalton? A point. Could you be more specific? Does anyone know what that's called? The point is the graph of it, but what is it called, what he's describing? No, an intercept is, well, it can be a solution, but when you write an intercept, what does it look like? You guys are going to kick yourselves when you hear this. Sebastian? No, a solution is not a line. A line is a graph of all the solutions. This is a huge problem for this group, that we don't know this. So if you walk out of this room today and you still don't know it, that's a huge problem for me. Well, be more specific. You're close. Guys, I'm looking for two simple words. Yes, Nathaniel? Yeah, an ordered pair, ladies and gentlemen. An ordered pair is a solution to this. This is basically everything you were supposed to have learned for the entire first 4 months of school. Is that an ordered pair is a solution. This is a graph of ordered pairs. Solutions to an equation that has two variables is an ordered pair. What is that? That's x. That's y. What's an ordered pair? X comma y. So a solution is an ordered pair. I'm telling you right now, if you walk out of this room and come back on Wednesday, and I ask you what a solution to this will look like, and you can't tell me ordered pair, I'm going to throw you out the window without opening it. You cannot walk out of this room and not know that. I don't know how else to explain it to you. It's critical. It's one of the most critical ideas. So now, we're moving forward. So you guys are going to have to catch yourselves up. Because a solution of a system is an ordered pair. But it's an ordered pair that solves both of the equations in the linear system. Again, a solution of a system is an ordered pair that satisfies each equation in the system. Now, a system can have more than two equations, but you'll get to that when you get into Algebra 2. This year, you only have to know how to deal with a system that has two equations. Now, my hope is that my students will instinctively understand what to do by the end of today. But in case your instincts don't kick in, I always write out the steps as a sequence for you to write down so that you have something to fall back on. So, here is how to solve a linear system using the method called graph and check. Step 1. Graph both of the equations in the same grid. You can use any method that you would like to graph. During the warm-up, we had some people say they used intercepts, and we had other people who said they used slope-intercept form. Both methods are appropriate. Both methods are wonderful. Step 2. Here's the part that's going to be new for you. Find the point of intersection. The two lines that we're going to draw are going to cross at some point. The point where they cross is called the point of intersection. The coordinates of that one point is the solution to the system. Now, this is a tough strategy to use. Unfortunately, a lot of times we're off by a little bit. So to make sure that we actually find the correct solution, we have to check it. And we check it by plugging the ordered pair back into both equations to make sure it works. Now, if none of this makes sense, that's perfectly normal. I haven't even shown you what a system looks like yet. But you're going to see a system in a moment, and then it will all start to fall into place. Now, I know you guys are copying feverishly and using lots of abbreviations, but if you're still not done copying, that's okay. I have it printed out right here, and if you're missing anything, you can just leave a couple of lines of space and fill it in at the end. But I'm going to move on to the first example. And what we're going to do first is we're going to learn how to do step 3, which you already know how to do, but you've never seen it quite like this. Yes, John? Right up here. So, example 1. Decide whether each ordered pair is a solution of the linear system. So, for the first time, you are seeing a linear system, and there is a system. It's two equations together. That's a system. Now, I would like to know, in part A, is the ordered pair -6, -4 a solution to the system? Well, let's forget about the system for a moment, and let's just use what we already know. Let's pretend that that's not there for a moment. If I asked you to tell me if this was a solution to that equation, how would I accomplish that goal? If I just wanted to know if that ordered pair was a solution to the equation. I've got 3 people who have an idea. Go ahead, Michaela. How can we figure that out? You said that beautifully. You plug in the ordered pair for the x and the y and see if it comes out true. So we're going to take this x value, put it there, put this y value here, and see if it makes a true statement. If it does, then we know that it works. So let's do that first. -6 minus 3 times -4, and we're asking ourselves, does that equal 6? So let's do some mental math. -3 times -4, what do we get there? -3 times -4. Go ahead. 12. And then we have a -6, and so 12 and -6, we get +6. So this is a true statement, and so that means this is a solution to this. This is a true statement, so this ordered pair works for this. But now we're introducing the new idea of a system. And so now I'm saying, for this to be the solution to the system, it also has to work in this equation. So we're going to do the same thing, but we're going to do it in the second equation. The x is going to go here, the y is going to go here, and we're going to see if it equals negative 8. 2 times negative 6 minus negative 4, does that equal negative 8? Do some mental math. 2 times negative 6 is negative 12. Minus a negative 4 really means plus 4, so we have negative 12 plus 4. What do you think? Caleb? So is it true? Yeah, it's true. So we get a true statement here as well. And so what we have just figured out is that this ordered pair, yes, is a solution to this system. Does anyone have any questions on how we tested it out? Because this is something you're going to be doing over and over again. No questions. All right, so let's check part B, this ordered pair, and let's see if this one is a solution to that system as well. So now we're going to plug in a 0 in place of the x, minus 3 times negative 8. Does that equal 6? Nathaniel, what do you think? No, it doesn't. This is a false statement. Once we get a false statement with either of them, then you're done. You don't have to do anything else. You already know that this is not a solution. The answer is no. It's not a solution to that system. Are there any questions on how to test a solution? Okay, give me a thumbs up if you feel comfortable with the idea. Okay, good. Put your thumbs down. So if some of us not quite comfortable yet, but that's okay. You'll get there. No comments or questions? So that was step 3 in the process. So now we're going to do a new question where we're going to do step 1, 2, and then 3. So now we want to solve a linear system by graphing. It's called graph and check. So the system that we're going to graph is right here. 5x plus 4y equals negative 12. 3x minus 4y equals negative 20. Again, I would like to relate this back to what you already know, so I'm going to white out some of this so that we can focus for a couple of minutes while we're learning. So let's pretend, just for a couple of minutes, that this nasty thing is not here. And now I can breathe a little bit. Okay, it's just one equation. I can graph it. I just did it during the warm-up. So now think back to the warm-up and what you did there. Now, a few people got it wrong. A lot of us got it right. The people who got it wrong should have learned where they went wrong. And now everyone should feel comfortable on a method for graphing 5x plus 4y equals negative 12. So what could we do to graph this equation? Just 2 people have ideas? 4 people? 5 people? 7 people? Okay, Janae, what's your idea?
First, get the x minus 1.
Good.
Then next, get the y minus 1.
Good. Very good. What's that process called, Matthew? Well, was that the method you were going to talk about? Okay. You don't know what it's called, though? Can you think of a key word in there? Okay, so 0 is going to come into play. Kadir? Yeah, intercepts. Janae is talking about finding intercepts. So if we plug in a 0 here, this disappears and we end up with this. 5x equals negative 12. And so now we're finding the x-intercept. Divide both sides by 5 and we get x equals negative 12 fifths. Any questions on how we did that? That's the x-intercept. Now the y-intercept. As Nathaniel taught us during the warm-up, now replace the x with a 0. And we end up with 4y equals negative 12. Divide both sides by 4 and you get y equals Valerie? Negative 3, very good. So we have the x and y intercepts now. Now this number right here, since we're talking about graphing, and I have to graph that number, that's nasty looking. Is there a better way to write that number that would make a little more sense? Maybe make it a little more human? If I saw that on a sign on a highway, how would it really be written? It wouldn't be negative, but how would it be written? Andrew? Close. Not negative 1 and 2/5. Very good. Excellent job. So this is really negative 2 and 2/5. That makes a little more sense. Now you can tell that that's somewhere near negative 2. Okay? So now we want to graph this. So we need a grid. So set up a grid, or hopefully you either already have it set up or in the process of setting it up. So now we want to graph these intercepts. The x-intercept is negative 2 and 2/5, and the y-intercept is negative 3. So the x-intercept, negative 2, negative 2.5 is there, negative 2 and 2/5 is going to be a little bit less, about right there. And the y-intercept is negative 3, so that's a little more friendly. Negative 1, negative 2, negative 3, right there. And now we need our line. So this is nothing new. You've done this. You've been doing this for months now. Graphing a linear equation. I'm being honest, you should be an expert. An absolute master of doing this. So now here's where things change a little bit. Is that it's a system. And so we do have a second equation. But think of it this way. Now I'm just asking you to graph this one. And pretend that the other one's not there. That's no big deal. So now we want to graph 3x minus 4y equals negative 20. And I think Janae's method is an excellent choice, finding intercepts. So if we make the y equal to 0, this will disappear, and we end up with 3x equals negative 20. Divide both sides by 3, and we get x equals negative 20 thirds. And now make the x into a 0, and we are left with negative 4y equals negative 20. You could just do mental math for that. Y equals 5. So again, we found the x and y intercepts. This is an ugly looking number. Can someone write it in a way that is more meaningful to us? Michaela? Very good. Negative 6 and 2 thirds. That's much more meaningful. So now we're going to graph these two numbers. The x-intercept, negative 6 and 2 thirds. So negative 1, 2, 3, 4, 5, 6, and 2 thirds is going to be somewhere around right there. And then the y-intercept was 5. 1, 2, 3, 4, 5, right there. And again, connect the dots. You want your line to go all the way through. All the way through. Accuracy is critical. So we have graphed the system. This is the graph. But the purpose, the reason we graph is to actually find something. We're trying to find the solution. So now I want to do something. Before we actually get to the solution, I want to talk about this. I don't want you to do this. I just want you to watch up here. If I take the coordinates of that point right there, and I plug it into the system, what will happen? If I take the coordinates of that point right there and I plug it into the system, what will happen? Sebastian, your hand up went up pretty quick.
The first equation will be right with the here.
Very good. That was outstanding what you just said. Since it's on the blue line, and the blue line is representing the first equation, that ordered pair will work in the first one, but not the second. What about this point right there? If I plug that into the system, what will happen? Valerie? Good. It will be a solution to the second equation. You meant equation, right? Second equation, but not the first. So which point will work for both of them? Where can I find the point that will work with both of them? Next hole? Yeah. And what's that called? The point you said for both of them? Stephanie? Yeah, the point of intersection. Where the two lines cross, right here, that is the solution to the system. The solution to the system has to work for both of them. So my two orange dots only work for one of the equations. Oh, and just another point. What if I picked this point over here? Oops, excuse me. What if I picked that ordered pair right there and I plugged it into the system? What would happen? Edgar? It wouldn't work with any of them because it's not on either line. Okay, but the red dot should work for both of them. Now, the lines were kind of hard to draw because of these ugly numbers. This ugly number here and this ugly number here made our lines a little bit difficult to draw. So it is possible that our lines are not perfect enough. So we have to test out the coordinates. So first let's identify the coordinates. What is the ordered pair for this point? Excuse me. What is the ordered pair for this point right here? Look at your paper if you have to. You have it right there on your paper. Davis?
X equals negative 4 and y equals 2.
Yeah, negative 4, negative 1, 2, 3, 4, comma 2. So we think that the solution is negative 4, comma 2. But before we pat ourselves on the back and do a little cheer, we need to check and make sure that that's the right point. Because again, if our lines are accidentally off a little bit, maybe it was supposed to cross over here. Or maybe the blue line was supposed to be over here. Or maybe the green line was supposed to be a little bit down here. So it's a little bit hard, it's hard to know if we got it right. So we're going to check it. And so we're going to plug the coordinates back into the original system. So here we're going to check. So we're going to plug in negative 4, comma 2. 5 times negative 4 plus 4 times 2. That's the ordered pair right there. Does that equal negative 12? Do some mental math. Does it work for this one? Galatian? You sure? Edgar, you think it works? Yeah, it does. That's a negative 20. That's a positive 8. Negative 20 and 8 is negative 12. So it works for the first equation, but now we need to make sure it works for the second one. So 3 times negative 4 plus, minus 4 times 2, does that equal negative 20? Matthew, you already figured it out? Oh, I'm sorry, I saw you look like you were finished. So, John?
Yeah.
It works? Dalton, does it work? You sure? Let me see. 3 times negative 4 is negative 12. That's a negative 8. Yes, this works as well. So, since it works in both of them, that means we found the correct ordered pair. And so the solution to this system is, negative 4, comma 2. That is the solution to the system. Does anyone have any questions on how we did that? How we arrived at that point? Why we were looking for that point? Anything at all? Okay? No questions about anything. Okay. Checkpoint number 1. You're on your own. This process takes quite a bit longer than other ideas that we've studied. You got 6 minutes. Take another minute. You have to finish. Not optional. Good that you did that. Don't erase it, don't cross it out. Now you know that's not the right answer. Okay, now your time is up. So, what did you get as the solution for the system? Solution for the system. We'll start with Valerie, Kadir, Extol, and then Michaela. Valerie. Okay. You got the same thing as her, okay. Really? Wow, I got 3 people who agree. That's amazing. I have 4 people who agree. This is the first time that's ever happened with this question. The correct answer is -3, -5. I'm amazed and very proud. Here is the graph. So for my students who did not get this, you're going to be amazed at the mistake that you made. Because most of you put the graph wrong. Here is what the graph is supposed to look like. Many of you have one of the lines going the wrong direction. Many of you have one of the lines going way up here, this way. So it definitely was not easy. One of the intercepts comes out to a somewhat ugly number, not really that bad, but comes out to -3.5. But one of the intercepts was, this was -3.5 and 7. And then for the orange one, it was 10 and -2. So really the only intercept that was a tiny bit challenging was this one right here. But I don't really think it was that challenging, -3.5. And then when you connect the dots and draw the lines, you end up with this point right here being the point of intersection, and that's -3, -5. Now, I was very proud of some of you who got the wrong answer, but you checked and you knew that you had gotten it wrong, and then you were in the process of going back and trying to find the right answer. You were just having trouble finding it. The reason you were having trouble is because one of your graphs. Okay? Are there any questions on how this was done? So you have learned a method of solving a system called graph and check. The larger idea that we are trying to become masters of is applying a system to a real-world scenario. So I'm going to do 2 real-world scenarios with you. When I put up the example, you're going to write the name of the example, but you don't have to write the question. You're just going to read it. Read it to yourself. So here we go, example 3. Now, we've done a lot of real-world scenarios over the course of the year. But most of them involved one scenario or one person who's always revolving around one situation. Now we're talking about systems of equations with two equations, and so now we're going to be exploring problems that have two different things going on. So you already read the question. We have two people. Both people are trying to accomplish the same goal, they're going about it differently. That's where a system comes in. Because we can describe one person with one equation, describe the second person with a similar yet slightly different equation, and then we can do something with that. So your job here is to start learning how to interpret a situation like this. So let's just start with one person. Let's start with Bryce. Excuse me. So how can we describe Bryce's situation using algebra? Well, this is something we've been talking about since the beginning of the year. There are three things that I've asked you to look for when presented with a real-world scenario. Could someone give me one of the things I always ask you to look for? Dalton? Flat fee. What's another thing I always ask you to look for, Stephanie? Total. And what's another thing I ask you to look for, John?
Rate.
A rate. If you can find those three things, you can set up an equation. But sometimes it's a little bit more complex. Michaela? And then the missing piece. Now, we are working with two variables, so there's two things missing. So let's just look at Bryce's situation. It says, Bryce's account had a balance of $2,000, and he plans to deposit an additional $50 per month. So here's the information we have to work with. We have $2,000 and then $50 per month. I've highlighted two things. Can someone give me the word that describes one of those? In other words, 2,000 is the what? Go ahead, Kayla. Yeah, she's right. And that was actually hard. She said it very casually, like it was no big deal, but in my other group, it was very hard for people to see that that's actually the flat fee. Because a flat fee is also known as a starting point. And for Bryce, his starting point is $2,000. What about the 50 per month? What do we call that? What do we call that? Valerie? That's the rate. So, can someone now take these two pieces of information and put them together into an equation for us, or start us off at least? Nathaniel?
Y equals 50 and plus 2,000.
Very good. Y equals, and we're going to stick with an X just because we're using X's and Y's, 50, and he said M because of month, but we're just going to use X. Y equals 50X because it's the rate times the number of months, but you have to add in his starting point, which is the $2,000, the flat fee. So now we have an equation to describe Bryce's scenario. Anyone have any questions about that? Now, if you have no idea how Nathaniel came up with that, if you're not seeing it yet, you should at least be able to look at that and now come up with Julia's based on what you see here. Because now let's look at Julia, which is the other person in this whole story. So now without any prompting, you should be able to put together Julia's equation with no problem. So what's Julia's equation going to be? 1, 2, 3, 4, 5, 6, 7, 8, 9. Got the same 9 people volunteering all stuff. I'm proud of you guys. Davis?
Y equals 100x plus 1600.
Very good. Y equals 100x plus 1600. And my other 8 or 9 volunteers, I hope that that's what you were going to say as well. So now we have the two equations. Now we're asked to predict when they will have the same amount. When will they have the same amount? Well, we're learning how to do graph and check, so we're going to use graphing to do this. And I provided you as a time saver, this is purely to save time, I've provided you with a grid that's set up perfectly for this already. So if you would have that in front of you, and of course you're going to need your ruler and your pencil. I'm just going to move this down a little bit. So now we want a graph. John, go ahead.
I don't know the way.
You already know? Is that what you said? Go ahead.
Like, when you, for the rate, you have 50 over 1 month,
Very good.
and then you use the
Okay.
and you have to find the rate and the starting point, and then you multiply it.
Okay. Well, you might be right. Now, is that a way to graph and find it, or is that a way to calculate it? Okay. So that's good, because you're going to learn more about that the next 2 lessons. But today we're learning how to graph. So let's look at the equation in blue. What form is that equation in? Every single hand in the room should have gone up, because every single person should know what form that's in. Chris? Slope-intercept with a question mark? Yeah, slope-intercept form. You should be intimately familiar with it. And so when I want to graph something in slope-intercept form, where do I start? Where do I start? Edgar? Yeah, what is the y-intercept? 2,000. This is our starting point right here. So we start right here at 2,000, and then we rise 50, and just as John said, this really means 50 over 1. So it's a rise of 50 over 1, rise 50 over 1, there's another dot, rise 50 over 1, I could put a dot there, but I'd rather it be on the lattice. Rise 50 over 1, right there, there's another dot. And now I can draw a perfect line. And so now I have the equation that represents Bryce. And I now have the graph that represents Bryce. So what about Julia? How do I graph Julia? Good ear? Very good. I'm going to start at 1600 right here. And then, yeah, 100 up over 1. 100 up over 1. Now I've got enough to draw a nice accurate line. So the question was, or we were actually asked to predict when they will have the same amount of money. So when do you think that they will have the same amount of money in their accounts? John? 7, 2400. Okay, so 7. Okay, so after how many months? Yeah. Right here, right where they cross, if you go down, it's at 8 months. And if you check that by plugging in an 8 in place of each equation, if you plug in an 8 right there and an 8 right there, you will find out that they will both have 2400. And if you continue this scale up here, this line right here represents 2400. So that coordinate, that point is 8, 2400, just as John said. Go ahead, Dalton, and then Stephanie.
I was thinking maybe you could solve it.
You think you can solve it mentally?
Yeah.
If you can, more power to you. Unfortunately, though, for you, I am asking you to learn how to graph, and so that was really the goal here. Yes, as John pointed out, there are other ways to find the answer, but we today are learning how to graph and check, and so that's the purpose of the question. Okay? Any other comments or questions? Okay, if you would please put your pencil and your ruler down. I have one more example, but I just want to basically show you quickly. It's not a very effective way to teach, but I want you to have more time to do your classwork, so I'm going to go through this quickly. So if you would first start out reading the question to yourself, and then I'm going to demonstrate. So this is a classic, and I mean classic, like this type of question is used all over the country, all over the world, on every test, every quiz, everything is going to be a question like this. This is a classic system question. There's a dead giveaway on how to know. There's 2 totals. There's 2 totals. Can someone tell me what the 2 totals are? What are the 2 totals, Michaela? Those are not totals. Those are something else. Looking for the numbers that represent the overall of something. Extol? Yeah, 15 is a total. That's 15 bottles. And then 26 is the total amount of money. So you can immediately tell that it's going to look something like this. So the question is, what goes on the left? So let's forget about the second one, and let's just talk about the first one. What is going to add up to 15? Daniel? Right, but there's 2 different types of juice. And so if we say that apple juice is X and orange juice is Y, then what would I put over here to complete the equation? Danielle? Okay, so you have a good idea, but it's misplaced. Because you introduced money, but is this number have anything to do with money? What does this number have to do with? Sebastian? Yeah, it's a number of objects. So if X represents the number of apple objects, and Y represents the number of orange objects, and there's 15 objects altogether, what would I put on the left-hand side to complete the equation? I see some light bulbs going off. Caleb? X plus Y. X is the number of apple juice bottles, Y is the number of orange juice bottles, and 15 is the total number of bottles. Think of it this way. If I said that I bought 5 bottles of apple juice, how many bottles of orange juice are there? 10. That's simple. So now here's where Danielle's idea comes into play. Because now the money has come in. So now we take the rate with the variable and the rate with the variable and then complete the equation. So now we have 150x plus $2 times the number of bottles, and that will come out to $26. And now we have a system set up that we could graph and solve. Okay? So I know, again, this is not the most effective way to teach, but in the interest of time, it is what I wanted to do to get through it. Okay? So you're going to immediately see something like this when you do your classwork. So, draw a line across your paper. Your classwork is, on page 73, you're going to do numbers 22, 21, 19, 16, 11, and 4. All right, you guys have given an outstanding effort. Let's see how we did. Number 22 was very challenging because of the ugly numbers. Here is what the graph should have looked like, but it was very hard to find the exact ordered pair because the graph was not the friendliest graph that was given to you. So, I was impressed. I saw a lot of what you did. A lot of you were on the right track, but it was just very hard to find that exact point. So you had to estimate and then check it to see if it was right. It comes out to exactly 8 blooming annuals and 16 non-blooming. Number 21, let me move this up a little bit. That's the graph, and the solution is 2, 7. Number 19, here's the graph, and the solution is negative 3, 6. So those came out a little bit more friendly. The publisher sometimes likes to go by threes. I don't ever go by threes, so I would not expect you to do that. So your graph should look similar, but just a different scale on the x and y axis. Did anyone go by threes? I wouldn't imagine so. You did? Okay, good. And number 16, there's the graph. The ordered pair is negative 3, 0. Number 11 was kind of a giveaway question. All I was asking you to do was look at the graph and find the ordered pair and then check and make sure it's right. And then number 4 was just checking a solution. So in the interest of time, I'm just going to assign your homework. If you are having any concerns or questions, come to my care class tomorrow morning, and I'm more than happy to devote some time to you. So your homework is on page 442. You're going to do numbers 10 through 34 even and number 38. Starting today, moving forward, we are going to be using a special section at the beginning of the textbook called the countdown section. So the page numbers start with FL. So So you have to find page FL12. Don't go to regular 12, that's not the right page. FL12, and you're going to do day number 1, day 2, day 3, day 4, and day 5. Each day has one question, so that's 5 questions. These are all EOC review questions. And we're going to be doing these for the rest of the quarter and beyond. Then you're going to read the next section. That is going to give you a huge insight into what we're doing next. And your first quiz of the quarter will be next week. And it's going to be 7.1 to 7.4.